Okay, so this one on page 7, number 2, is a regular hexagonal prism. That means that the bases are regular hexagons. Regular meaning all 6 sides are the same length, and all the interior angles are congruent. Notice this hexagon in the back is congruent and parallel to the hexagon in the front. When we find the volume and surface area, we have to make our list. We have to find capital B, capital H, and P. What does capital B stand for, you guys remember? Thank you. Area of the base. Not just base, right, but area of the base. So, when we look at the shape of the base, regular hexagon, that's what tells us that we're going to need to use 1/2 AP to find the area, because the base is a regular hexagon. And our formula for regular hexagons is 1/2 AP. Okay, the height, capital H now, capital H, is the distance between the two bases. The perpendicular distance between the two bases. Okay? Lowercase h, we've used in our formulas for area, 2-dimensional shapes. Height of the triangle, height of the parallelogram. Capital H we're going to use with 3-dimensional figures as the height of the entire prism. Now, if I ask you how tall you are, tell me you're 5'7" or whatever, and then I say, well, lay down on the floor. Now how tall are you? Would you tell me something different? No, you would still say, well, I'm 5'7", I'm just laying down on my side right now, right? You wouldn't start measuring from here to here now. You're going to measure your height. Same thing with a prism. Okay? This prism, here's one base, here's the other base. The height connects those two bases. Distance between the two bases. If I lay it on its side, this is still the height. Okay? So base doesn't mean bottom, and height doesn't mean from the ground up. All right? So you have to kind of keep straight those sort of new definitions. So height in this particular problem on this diagram is what? What's the height? 12. 12 is the distance between those two hexagons. All right, perimeter is just the distance around the base, right? And again, we're not talking about a rectangle as a base, right? Base does not mean bottom. We're talking about the distance around this hexagon. So there's 6 sides, each side is 8, so 48 here. All right, well, 1/2 AP, we're going to do 1/2 apothem times perimeter. Well, we just figured out perimeter is 48. What's the apothem? Okay, so this is where we got to remember. We pull out this right triangle. If the whole side is 8, this is 4. This is a 30, 60, 90 triangle, which makes the apothem 4√3. So 1/2 times 4√3 times 48 is 96 root 3. So that's the area of the base. All right, so surface area is BH plus 2B, and volume is BH. So for surface area, P is 48, H is 12, plus 2 times the area of the base, 96 root 3. Sorry, I'm not. Now, be careful here, because if they ask you to leave it in terms of exact form, if your answer is an exact form, okay, then you have to leave the radical in your answer. And this one comes out to a whole number with a radical. We actually can't add them together. So 48 times 12, 576. And this is 192 root 3. These two things cannot be added together. You can't do 576 plus 192. Because that root 3 works kind of like a variable, right? So this would be like doing 5 plus 2x. You have to leave it as 5 plus 2x. All right, volume. Area of the base times the height. So 96 root 3 times 12. $11.52 root 3. Now remember that units for area, surface area is square feet, and volume is cubic. All right, any other questions? Does that one make sense? Are they going to have you turn to page 9? I will skip page 9, but I want to look back at the things on page 9 now. So this first one, I just want to point out that with rectangular prisms, every single side could be considered a base. Right? It's not as defined as with other types of prisms. Clearly, the two pentagons are the bases here. But here, all the sides are rectangles. So how do you know which ones to use? Well, what you want to make sure you do is just pick one and stick to it. So you may want to use this as your base. Or you may want to use this as your base. You could even use the front as the base. Whatever you do, I recommend shading it in so that you don't forget that that's your base. And then everything in your list pertains to that base that you chose. So I'm going to use actually this, what I shaded yellow here. I'm going to choose this right side as my base. And obviously there's another congruent parallel one. Now, when I go to make my list, everything has to do with that base. Capital B, area of that yellow base is just base times height, right? So 6 times 5, which is 30. If that's my base, what's the height? 11 is my height. Perimeter is the perimeter of that yellow piece, right? So 6 plus 5 plus 6 plus 5. Like, once you have that list done, everything is just plugging. So, 3H, 22 times 11, plus 2 times 30. Now, make sure on a test or whatever, you show me that list, and you show me all your steps. Okay? You have to show your work to get the credit here. It works to your advantage, actually, because some of these problems are time-consuming. So I can't put, like, 30 questions on the test. There's going to be like 10. You know what I mean? They take a long time. So if I only have 10 questions, and everything's going to be worth like 8 points or whatever. So the list itself is worth like half a point. So you got to make sure that you're showing everything so you get all those points. All right, so 22 times 11 is 242. Plus 2 times 30 is 60. Make sure you calculate those separately, pH first, and then plus 2b, and then add them together. So 302 square centimeters for surface area. And for volume, we're going to do 30 times 11. (330 cubic centimeters). All right, you guys try to do this with it. Pick which piece you want to be the base, and find the whole list, and then surface area and volume. All right, so how many people use this as the base? All right, how many people use the one they shaded as the base? All right, how many people use the front as the base? Okay, we have one of everything. All right, so the fact is, no matter what you chose, your list is going to look different based on which one you chose. But your surface area and volume sound the same. So if we did this as the base, that's 7 by 4. That's 28 for your V. Height would be 10. Perimeter would be, what did I say? 22. Now, if we did this as the base, that's 10 by 4, so that's 40. Height is 7, and perimeter would be 28. So these combinations of numbers, believe it or not, when you do surface area, pH, 22 times 10 plus 2b is 220 plus 56, which is 276. If you do these numbers, 28 times 7 plus 2 times 40, you're still going to come out with 276. Right? So the combinations will still work. So you should have gotten 276 for the surface area. Again, that's square centimeters, and volume would just be 280 cubic centimeters. questions on that? All right, some of these other ones on page 9 are similar to ones that we did with just area, where you kind of have to work backwards to get the missing dimension. This one, number 12, says find the radius if you are using volume of a cylinder. And here is finding radius if you're given the surface area of a cylinder. Now, remember that with cylinders, the bases are circles. So when we have surface area equals pH plus 2b, I mean, that's kind of what I memorized that. With a circle, you just have to make the one change that it's a C instead of a P. Right? Circumference instead of, for instance. Volume is still the same. Now, however, in order to solve for radius, you have to work with a formula that has an R in it. Right? Otherwise, it would be hard to solve for radius. So you have to turn this into a formula that has R. So you're going to have C is 2 pi r, because circumference is 2 pi r, right? So you end up with 2 pi r h plus, and capital P is pi r squared. So you end up using this formula instead, because to solve for radius, you need a formula that has an R in it. Does that make sense? Okay, so if the, this one's volume. Okay, same thing. Volume is pi r squared h. So same thing down here. I'm just going to move this down. 2 pi r h plus 2 pi r squared. That one's going to be our surface area one. Does that make sense? So, I mean, I'll probably give you these formulas anyway on the test. I don't know. I usually don't. I'll have to talk to my other math teachers. But when we would memorize them, I would encourage people, don't try to memorize all the different craziness. Just remember the basics. pH plus 2b. You can remember that a P in a circle is really a circumference, right? And then that turns into 2 pi r. Okay, so you've got pi r squared h equals the volume, and they're telling us that the volume is 960. So we're just going to plug in what we know and solve for what we don't know. 960 pi equals pi times r squared times our height is 15. So to solve for this r, we're going to divide both sides by pi, which gets them to cancel, and divide by 15. So 15 into 960 goes 64 times. So 64 equals r squared. What would radius be? Square root of 64? So if the radius is 8, find the area of the base. Well, that's just pi times 8 squared, or 64 inches squared. All right, number 13, if a cylinder has a surface area of 144 pi, we're going to use again this formula where we have an R in it. Height they're telling us is 21. Well, I'm going to rewrite this. In standard form, meaning the r squared I want to come first. This is 42 pi I'm going to bring this over also. Here is equal to 0. Because if I'm trying to solve for r, and there's an r squared and an r, how am I going to have to do it? Square rooting would work if there wasn't this r here. If I have a, let's say I have an x squared and an x, how would I solve this? Factor, we have to factor. Well, first thing we want to do is get rid of those pi's, because those are just annoying. Right? Divide everything by pi. We've got 2r squared plus 42r minus 144. What else can I divide by? To make our lives easier, what can we divide by? 2. So we'll have r squared plus 21r minus 72. If the first term is just r squared, we're going to do r and r as our first terms. Now multiply to be 72 and add to be 21. Anything here that could add to be 21? Add or subtract, combine, be 21. Yeah, Campbell.
24 minus 3.
Yeah, 24 and 3. Right? So if you're stuck and you're like, I don't know what multiplies 72 and add to 21, just make a list of everything that multiplies to 72. You're bound to come up with it, right? So we've got 3 and 24. In order for it to be a negative 72 and a positive 21, we need a positive 24 and a minus 3. So radius is equal to 3 or negative 24. Can a radius be negative 24? Radius of a circle, can it be negative? Nope. So, make sense? Yes? Okay, any questions on that? Alright, so we're going to move on to 7.2 notes, which basically is introducing the idea of pyramids and cones. Last time it was things with 2 bases, and now we're talking about things that have 1 base and come to a point. A lot of things are very similar here. Obviously, we know what volume is, we know what surface area is. A pyramid is a polyhedron that has 1 base, and the lateral faces are what shape? These are lateral faces. What shapes are they? Triangles, right? So instead of being connected by quadrilaterals by prisms, these are pyramids. So they have triangles on the sides. And they meet at a point at the top. Okay, so just like prisms, a pyramid is named the shape of its base. So it has a hexagon as a base, it's a hexagonal pyramid, etc. The altitude, which is what we measure to get the height of the pyramid, is actually from the vertex, from that tipping point, straight down, as if you could drop a rock. You know, if you were standing at the very top, you dropped it straight through the middle, like this. Right? The altitude goes from the vertex straight down perpendicular to the base. You can really land right in the center of the polygon at the base. So that's altitude, which is what we use as the height, capital H, of the pyramid. Alright, a regular pyramid has a regular polygon as the base. Like I said, we're going to be using all regular pyramids, so if it's not specified, you can assume that it's a regular polygon as the base, okay? Alright, the new term here is slant height. The slant height, we don't have slant heights on prisms. We only have slant heights on pyramids and cones. This one is pretty clearly marked here, right? You can see this black mark right here. That is the slant height. It's basically the height of the triangle face. So it ends up being kind of slanty height. Slant, okay? They use in lowercase script L to mean slant height. The slant height is part of the formulas, but it's also really important to identify because in pyramids and cones, we have, again, a hidden right triangle. You kind of got this triangle that you can pull out and use to help you calculate any missing parts. I'm going to try to show you with my paper here. So you can see, I don't know if you can see this at all, but if you imagine the altitude down, from the vertex straight down, like I was holding my pen before, and then the slant height on the side there, and then if I connected those two along the base, you would have this triangle, right? So it's that right triangle that you want to sort of identify and use, again, Pythagorean theorem, SOHCAHTOA, special rights, but in most cases it's going to be Pythagorean theorem for these, okay? So you've got the altitude down, you've got the slant height here, and then we connect it like this. Now, that connection right there, can you picture it on the base of the pyramid? What would that length be called? Imagine I have this triangle, right? I put it in there. And I'm talking about from the center to the edge. What was that called? Begin with an A. Yeah, the apothem. Basically, you're connecting, this is slant height, this is the altitude, or height, and down here is basically the apothem of the polygon at the bottom. Okay. So in a cone, you also have a hidden triangle. You know the base of a cone is a circle. Therefore, when we draw this hidden right triangle again, instead of a apothem, what is this piece right here? From the center to the edge of the circle is called what? Radius. But it's the same idea. We still have a right triangle that you need to kind of finish up your list that you have to fill out to find surface area and volume. Okay, so this is just a reminder. Capital B means area of the base. Capital H is the height of the whole figure. C is the perimeter. Again, if it's a cone, it's going to be a C for circumference. And L, lowercase script L, is slant height. So here's the formulas. Oh, this kind of ruins my demonstration there. I'm going to pause that. This formula is volume, capital VH, divided by 3, because the volume of a pyramid is 1/3 the volume of its related prism. So you can think of it as 1/3 VH, or as V times H, and then divided by 3. Be careful because, if you're doing 1/3 on your calculator, don't just put 0.3. 3/10 is very different than 3/9, right? 1/3 is 3/9. 0.3 is 3/10. It's different. So if you're doing 1/3 on your calculator, push 0.3333333, as many threes as you can fit, in order to get a more accurate answer. Okay? Or, like I said, you can do base times height, and then at the end divide by 3, and that will give you the same thing. Okay? Okay, again, if it's a cone, area of the base is pi r squared, because the area of the circle is pi r squared. So then we pi r squared divided by times h divided by 3, or 1/3 pi r squared. Sometimes you will see, cone written like this. It looks so different than what this is, but it's actually going to realize that's the same exact thing. It's just putting in the formula for area. Okay, surface area is 1/2 PL plus B. Now, think about this formula and why it makes sense. Let's go back to PH plus 2B. Remember that one? Surface area of a prism. PH plus 2B. Isn't this cool? I can take this out and unfold it. This is called a net. NET, the net of a prism is like this flattened, like pattern. So PH plus 2B is the area of this, basically this blue piece of plastic. PH. Now, plus 2B. Does that make sense? That you're adding plus 2B because there's 2 B's? Right? Makes sense, right? So plus 2B. That means that this must be the pH. This is pH, and this is plus the 2B. Make sense? Okay, so this is pH. What shape is this? It's a rectangle. How do you find the area of a rectangle? Base times height. Well, we said pH instead of BH.
Perimeter, right?
Perimeter.
But that's the piece.
But that is, right, the perimeter of this pentagon here is the length of that rectangle. You see it? See what I'm talking about? This length is the same length that wraps around that pentagon. So it really is, pH is really finding the area of this rectangle and then plus 2B. Makes sense, right? Okay. Wow. It's a little kookier, right? But does it make sense that it's plus 1B? Plus 1B because there's 1B. Alright, well, if I asked you what shape is this, you'd be like, I don't got a name for that. Right? It's not really part of a circle because these are all straight. So really, it's just a series of triangles. Well, how do you find the area of a triangle? Yeah, base times height divided by 2, or 1/2 base times height. Now, that height of this triangle we labeled as slant height. Slant height. So 1/2 PL is 1/2 perimeter, which is all these added together, times the slant height, which is basically finding the area of a triangle and multiplying it by how many triangles there are. Right? That's how the perimeter gets in there. Okay, so makes sense that if the spaces our triangles, we're going to have this 1/2 TL to get their area, and then plus one base because there's only one base. Okay, and again, with cones, it's 1/2 CL plus B. Same idea, circumference instead of perimeter. Turning them into their circumference is pi r L. The area of a circle is pi r squared. So remember that circumference is 2 pi r. So we have 1/2 times 2 pi r times L. You see how the 1/2 and the 2 cancel out? That's how we end up with just pi r L. Alright, so you might see it written this way, but remember, it's the same exact thing, just this diagram is here to remind you of our little demonstration. Alright, so let's try a few. Get a little bit more involved, so let's try a few together. So now we're on page 13 in your packet. Page 13. All right, first of all, name the pyramid. What kind of a pyramid is this? Remember, you're going to assume that the bases are regular polygons. So what kind of a pyramid is this? And what's a regular rectangle called? A square, right? Because all this, I know it looks not very square, but we're assuming that things are regular. So that really makes the bottom of this base, actually a square. Okay, so this is a square pyramid. And here's our list. Perimeter. Well, this side is 40 and all the sides are 40. That makes the perimeter 160. That lowercase l, slant height, is shown here. What is the slant height? 25. Good. This right here is the slant height. That's 25. Capital B stands for area of the base. Area of a square is base times height, or S squared. 40 times 40. 1600. Well, that leaves H, height. "95% of the time, when you have a pyramid or a cone, you're going to need Pythagorean theorem to find one of the missing pieces. So let's redraw that triangle here. That's this triangle right here. You've got H, you've got 25 as the slant height. What's this piece? Engine? Yes? What's this piece? 20, good. Because if the whole side across the square is 40, and the hypotenuse from the center down is just going to be 20. Be careful, because you're not always just going to take half the length of the side. It depends on what the base shape is, right? Works with squares, but doesn't work with other things. Okay, so Pythagorean theorem would be h squared plus 20 squared equals 25 squared. You may also recognize this as a 3, 4, 5 triangle in multiples of 5. Right? 3, 4, 5. 4 times 5 is 20. 5 times 5 is 25. So this must be 3 times 5. H is 15. Okay, well now we're just going to plug into our formulas. I do want to caution you though, there are some common mistakes that people make, especially with surface area. 1/2 EL plus B. Be careful, careful, careful. Sometimes people make the mistake of like dividing by 2 at the end. If you're going to do divide by 2 instead of times a half, that's fine, but you have to only divide the PL by 2. If you do PL plus B and then divide by 2, you're really only adding in half the area of the base because you're taking half of everything. You can't do that. You have to make sure the 1/2 only goes with the PL and then add the whole B. Okay? You got me? Okay, so 1/2 times P is 160 times L is 25 plus capital B is 1600. So 1/2 160 is 80 times 25 is 2000. And then add the whole 1600. So the surface area is 3600 square feet. Volume is VH over 3. Anything that comes to a point, you gotta remember to divide by 3. Right, so area of the base is 1600. Height is 15. $1,600 times 15 divided by 3. 16 times 5 is 80, so 8,000. Cubic feet. That makes sense? Okay. Next one is also a square. I don't want to do another square. I'd like to do number 4 next. This is a hexagon. I know it's hard to sort of see everything, but that's why I typed it all here. So that you couldn't read the diagram, it's written there. Alright, so we have named the pyramid. This is a hexagonal pyramid because the base is a hexagon. Identifying the shape of the base is important because when you do capital B, area of the base, you need to know what area formula to use. If this is a hexagon, what area formula are we going to use?
1/2 AP.
Good, 1/2 AP. H, P, don't forget to add the L. And it's slant height. When it's a pyramid or a cone, you have to have slant height on your list. Yep. Yep. Okay, so they tell us that the slant height is 9.
Miss Myers?
Yes?
For these, for the pyramids, are all the sides the same length on the base?
Yes, so we had mentioned here somewhere, wait a minute, I know it was kind of small and incidental, but right here. Assume a given pyramid is regular unless otherwise stated.
Okay.
So you're going to definitely make that assumption. I always say not to assume things, but this time we are going to assume that the polygons are regular. Okay? So, if the length of one side of the base is 6, and it's a regular hexagon, the perimeter is going to be 36. 6 sides, 6 each. Okay. Area of the base, 1/2 apothem times perimeter. Well, they tell us the apothem is 3√3. And the perimeter is, we just said 36. So that is 54√3. Now, again, if they asked us to put this in decimal form, we would just do 54 times root 3 on our calculator, put it in decimal. I'm going to have us practice leaving it in exact form. Okay? So, 54 root 3 is the area of the base. Now, height, we still have to tell. Remember, this triangle, I pull it out here. You've got slant height as the hypotenuse. This is the height, altitude down. This piece here is the apothem. So that's 3 root 3. So to calculate the height, we need to do Pythagorean theorem. H squared plus 3 root 3 squared equals 9 squared. Nine squared is 81. 3 root 3 squared. Careful now. Everything is getting squared. 3 is getting squared. What's 3 squared? Got it. Root 3 is getting squared. What's root 3 squared? Root 3 times root 3 is 3, right? Remember, squaring something that's square rooted cancels them out basically, and we get plain old 3. So 3 squared is 9, root 3 squared is 3. So 3 root 3 squared is actually 27, and times 3. So, h squared is 54. That makes h the square root of 54, which we can do as the square root of 9 times the square root of 6, or 3 root 6. Remember simplifying the radicals. We got 3 root 6 as our height. Alright, well now that our list is complete, we can find surface area and volume. Let's do volume first. The h over 3. So we've got 54 root 3 times, sorry, I'm squishing it a little bit here. I'm going to put it here. 54 root 3 times the height is 3 root 6 over 3. So basically those 3's cancel, and you've got 54 root 18. Can root 18 be simplified? Radical be simplified? Are there any perfect squares that go into 18?
9.
9. So this actually becomes 54 times 3, root 9 is 3, root 2. 54 times 3 is 162. So volume is 162 root 2. Let's surface area, 1/2 CL is 36, slant height is 9, plus 1B, 54 root 3. One half times 36 times 9 That's 18 times 9. Is that 162 too? 18 times 9. Yeah, 162. Plus 54 root 3. Now again, those two numbers, 162 and 54 root 3, cannot be combined. Because the root 3 has like a variable. So you can see how important it is to get the list right, but at least show your work in what you did to get the list. Because if, let's say, you screw something up here and your H is wrong, but then you plugged in your H correctly here, then you're going to get a lot of partial credit. Right? If I just put an answer line and said surface area and volume, and you get it wrong, and I just take off all the points, that would be losing a lot of points, right? So you really want to make sure you show your work all the way through so you can get credit for it. Okay, do you want to do one cone before the bell rings? So we've got the cone now, same list, except for we've got radius on our list now. The radius here is 15. Which means circumference is 2 pi times 16, or 30 pi. We're going to leave our answer in terms of pi. What's the slant height in this diagram? What's the slant height? 25, good. Right here, right? The height is missing, and it completes this right triangle. So for height, we're going to need to do h squared plus 15 squared equals 25 squared. Again, you might recognize that it's a 3, 4, 5 triangle. This being 3, the 4 being missing. 4 is going to turn out to be 20. Area of the base, well, it's a circle, so it's pi r squared. In this case, 15 squared. All right, once we have the list, we're going to plug it in. This area, 1/2 CL plus B. Circumference, I don't know what's wrong with my smartboard, it's doing weird things. C is 30 pi. L, 25. Plus capital B is 225 pi. Remember, pi's work like variables as well. So we're going to do 1/2 times 30 times 25, and we're going to get 15 times 375 pi plus 225 pi equals 600 pi. And that's surface area, so square centimeters. Volume, capital BH over 3. Area of the base, 225 pi. Times the height is 20. The whole thing over 3. So 225 times 20 divided by 3 is 1,500 pi. Cubic centimeters. Now, remember, it says state your answer in terms of pi. If I asked you to round this, you would multiply by the pi button on the calculator and then round your decimal answer. Remember, pi is approximately equal to 3, right? So you would expect 600 times approximately 3 to be greater than 1800, right? 1500 times approximately 3 would be greater than 4500. So you're looking for that multiple of pi. All right, any questions?